Okay, in this question, we need to actually get the regression line, the least squares regression line, from a set of data. So they give us this nice option to send the data to Excel, which we're going to do, and we will grab that data, and it'll look something like this. If you don't have Excel already loaded on your calculator or on your computer, I'd go ahead and do that. It's free for all JMU students. Just type in JMU software. Once you get that, you're going to go to Data and Data Analysis. If you don't see Data Analysis as an option, you're going to go through File, Options, Add-ins, okay, and then it'll pop up. Oh, maybe not. File, Options, Add-ins. Oh, here we go. And Excel add-ins go. Analysis toolpack, and you'll click OK, and then it should show up here. Once it shows up, it's going to give you this pop-up. You're going to go to Regression, and your Y range, we're going to include the label here, and then our X range, we're also going to include the label. The year is not one of our variables that they're asking if you read the problem. Labels, then, because we did include that top row, we're going to check labels and click OK. So this is how you run the regression. You could also do this in SPSS, like in our lab, first lab. The really important numbers here are down here where it says coefficients, and you can even see the intercept is labeled as the intercept. The slope there is just the other number. So let's see. Okay, I'm going to pull up a Paint and just write out what this equation would be. So we are predicting y, and if we want to, we could see that I forget what our outcome actually was, but we could write that variable that we're predicting here if we don't like writing a y. And then we have our intercept of 21.28 minus 0.54, we're getting that number from right here, times the non-US variable, or if you prefer, you can just write x there if you prefer that more algebra-looking equation. So that's how you run a regression and get your equation here. So if let me see. So notice they're using the y hat here. Oh, and they said 4 decimal places, unfortunately, which means I'm going to have to go back here and grab that to 4 places. Well, maybe I'll just cut and paste it. So this is my intercept, and then I can round that to 4 places, and then minus, and we need that other number right here. And we only need one of those minuses. You could also do plus and then have it as a negative. I think I had done that in class one time. That would be perfectly fine. And I'm just going to put an X here to represent the non-US. My guess is, Alex, if you type out non-US, it's not gonna like that. So this is our line equation for our line. Gets that right. And then these are more conceptual questions. So it says if the non-US emissions, which is that's our X value, if that would differ by 0.2 from one year to the next, how much would the US emissions differ? Well, what they're saying here, they want you to interpret the slope. So what change in y would happen with a 0.2 change in x? And we can get that. We can see if we plug in 0.2 for our x and multiply by the slope, that'll tell us how much our y would change for 0.2 in x. So I'm just going to do that on a calculator. Looks like we do not have a calculator available to us here, so I'm just going to do that on a separate calculator. I'm taking this negative 0.5374 times 0.2. 5374, and that'll give us negative 0.1075. And again, that was just the 0.2 times this negative 0.5374. And then finally, it says, what about when we have a specific non-US, and again, that's our X variable, non-US emissions level as 3.4. Well, here's where we go back to our equation, and we have an X value of 3.4, so we're just going to plug it in there and solve for our predicted US level. So I'm going to do that. 21.2848 minus 0.5374 times 3.4, and that's going to give me 19. It says 2 decimal places, so 19.46. Now notice that they could have given me a US emissions level, which would have been a Y value, and then I could have solved the equation for X. So that's certainly another thing that could have happened there. All right, so that's coming up with your own regression equation from the data and using Excel. You can do the same thing in SPSS or a TI calculator if you would prefer.